Welcome and hello everyone to Cyphernest Academy. My name is Muawiyah and I'm the founder as well as the CEO of Cyphernest Academy. And in today's video we're gonna start a new series about web fundamentals before we start the web hacking material. So we're gonna utilize TryHackMe platform and we're gonna solve the HTTP in details room. So let's get started. Starting with the first task, let's open the view site. Scroll down. What is HTTP? HTTP is called Hypertext Transfer Protocol. HTTP is what's used whenever you view a website developed by Tim Berners-Lee and his teammates between 1989 to 1991. HTTP is a set of rules used for communicating with the web servers for transmitting web page data, whether it's in a form of HTML, images, videos, etc. So what is HTTPS or Hypertext Transfer Protocol secure? HTTPS is a secure version of HTTP. HTTPS data is encrypted, so it's not only stopping people from seeing the data that you're receiving and sending, but also gives you the assurance that you're talking to the correct web server and not something or someone impersonating it. So basically the secure is that it encrypts the data that you send and receive from the server such that no one can try to look at your data or sniff it. So starting with the questions, join the room, and let's look at this one. What does HTTP stand for? We can just copy it from here, Hypertext Transfer Protocol. What does the S stand for? It stands for secure. And lastly, on the mock web page on the right, there's an issue. Once you found it, click on it, and what is the challenge flag? So looking at this website, it does look normal, but you can identify that it's using the HTTP instead of HTTPS, and it gives you the red sign that it means the website is not secure. So let's click on it, copy the flag, and let's just paste it on the answer. Great, now we can go to task 2. So request and responses. When we access a website, your browser will need to make a request to the web server for assets such as HTML, images, and download the responses. Before that, you need to tell the browser specifically how and where to access those resources. This is where URLs will help. So what is a URL? A URL is Uniformed Resource Locator, and if you've used internet before, you've probably used the URL before. A URL is predominantly an instruction on how to access a resource on the internet. The below image shows what a URL look like with all its features. It doesn't use all the features in every request. So let's take a look at it. Starting with the scheme or the protocol that you use. In this case it's HTTP followed by / username and password. So these are your credentials, and most probably here you're trying to log in into a website. At the domain name, tryhackme.com in this case, and then followed by the port number. The port number usually is linked to the scheme. In this case the port 80 is the default port for the scheme HTTP / and now you're giving it extra information. So you're telling it, I don't want to just access TryHackMe, I want to access the view room, which is the path, and I want to access this room, specifically the room with the ID 1, which is the query string, and inside that room I want to jump to task 3. So I can, in this example, look at my URL and let's click on it. See the full URL. We have HTTPS, meaning that it's secure. The domain or the host is tryhackme.com, and this is the path /r/room and /HTTP in detail. So in this case you saw that we don't have a query string, but we have a path to the room. So let's go to the request. It's possible to make a request to the web server with just one line. So you give it the method, which is a get or any other method, and then the protocol and its version. In this case it's 1.1, but for much richer web experience you will need to send other data as well. This other data is sent in what's called headers, where headers contain extra information to give to the web server you're communicating with. And let's check what is the headers that we have here. This is an example request. As you can see here, we have the method, which is a get, and then the protocol with its version. We have 3 headers in total here. The first header is host, and it tells the server which host it must go to. So in this case it's tryhackme.com, because you can have let's say a server that's hosting 5 to 10 websites. So the host header will tell it which website exactly to navigate into, and followed by the user agent. This tells the browser what's the user agent or the browser you're using. This can be for any compatibility issues or like if there's any features that the server need to take care of in different browser. The referrer tells the browser or from the browser tells the server what page was you located on before you send the request. And go down to the response. As you can see here, every response has something called status code, which is in this case 200 OK, and it has some other headers. Server date, content type tells me that the content that the server will give me, and in this case it's text and HTML. The content length of the data that the server is sending back to me. One last header that I forgot to mention on the client side is an empty line, and this tells the server that the request is finished. Let's go down, starting with the questions. What's the protocol used in the above example, it was HTTP with the version 1.1. Was the response header that tells the browser how much data to expect. That was the content length. And let's move to the third task. So HTTP methods are a way for a client to show their intended action when making an HTTP request. There are a lot of HTTP methods, but we will cover the most common ones, although mostly you'll deal with the get and post method. So the method that tells the browser what should it do with this request. For example, the get request is used for getting information from a web server. You're trying to fetch data or just accessing a website, probably use a get request. The post request, on the other hand, is used for submitting data to the web server or potentially creating a new record. So when you're registering to a new website or you're just sending a form, mostly you're using a post request. Put request is similar to post because it adds data to the server, but in this case the put request is to update information. So let's say you already have an email address and you just want to change it, so the request will not be a post, it will be a put request. And lastly, we have a delete request from the name, delete information or a record from the web server. So let's go to the questions. What method would be used to create a new user account? That should be post. What method would be used to update your email address? That's a put request. What method would be used to remove a picture? That's delete already. And lastly, it should be get request, but would be used to view a news article, and that's a get request. Let's move to the status code. View the site and let's read the paragraph that we have. In the previous task, you learned that when a HTTP server responds, the first line always contains a status code, which was a 200, informing the client of the outcome of their request and also potentially how to handle it. These status codes can be broken into 5 different ranges. You have the first range starting with 100 to 199, and these are called informational responses, and these are sent to tell the client the first part of his request has been accepted and they should continue sending the rest of the request. But bear in mind that these codes are no longer very common, so you might not identify the informational response, but you can see it sometimes in the wild. The 200 family is the success, meaning that the range of status codes is used to tell the client that the request was successful and the server processed the request. The 300 family is the redirect. These are used to redirect the client request to another resource. This can be either to a different web page or a different website altogether. The 400 is the client errors. Any error that happens from the client side to the server side, it's gonna be 400 or until 499, used to inform the client that there was an error with their request. The 500 is the server error, so this is reserved for the errors happening on the server side and usually indicate quite a major problem with the server handling the request, and this can be quite dangerous depending on what's the error. So let's move to the common HTTP status codes that you will mostly see. So there is a lot of different HTTP status codes, and that's not including the fact that application can even define their own. So even application can add a new status code. We'll go over the most common HTTP response. Starting with 200, okay, the request was completed successfully, and 201 means that a new data was created or a resource has been created. For example, a new user was added or a new blog was posted. So this will return back a 201. So 301 means moved permanently. This redirects the client browser to a new web page or tells the search engine that the page was moved somewhere else and to look there instead. So let's say you clicked on a link and that link forwarded you to a different website. This means that it used 301. 302 is similar to 301 redirect, but it's temporarily changed and may change back to the original server. So let's say I'm trying to navigate to try hack me and it sends me to a different server. Maybe it's just a temporary change because they are doing some maintenance on the server right now. 400, a bad request. It tells the browser that something was either wrong or missing in their request. So for example, the ID request that we saw up, let's say that I removed the ID and I didn't give it the ID. It might give me a bad request that it's requiring the ID parameter to be there. The 401, not authorized. You're trying to navigate to a page inside the website that's only authenticated page and you're not authorized, so you cannot view that page. The 403, forbidden, means that you cannot view this page even if you are logged in or not. The 405, method is not allowed. Here you're trying to send a request, let's say a post request with the create account. You're trying to create a new account and the default method should be post. but you change it to a get method, so it will give you that this method is not allowed to be used. 404, the page is not found. Basically, you try to navigate to a page that doesn't exist on the internet. And then 500, internal server error. The server has encountered some kind of error with your request that doesn't know how to handle it properly. Usually this happens when you're trying to hack a website and you do something that malforms the servers or the server, so the server just prompts an error to you. And 543, service unavailable. This service cannot handle your request as it's either overloaded or down for maintenance. And here we can just view the site and see different kind of errors. This is forbidden, this is not found, and this is the service unavailable. So let's start with the questions. What response code might you receive if you've created a new user or a blog? That's the 201. What response code you might receive if you try to access a page that doesn't exist? That's the default 404. What response code you might receive if the web server cannot access its database and the application crashes? So this means that the server was hit with the denial of service attack, or it has some maintenance downtime, and this is usually 503. What response code might you receive if you try to edit your profile without logging in first? So you're trying to access a page that should be for only authenticated users, and you're not authenticated in this case, so it should be 401. And let's move to the fifth task. Headers are additional bits of data that you can send to the web server when making a request. Although no headers are strictly required when making an HTTP request, you'll find it difficult to view a website properly because different headers can represent different meanings. Common request headers, these are for the client side when you're sending a request. These are the common headers that will be sent. First header is the host header. Some web servers host multiple sites. Providing the host header, you can tell it which one that you're requiring. Otherwise, you'll just receive the default website for the server. So in case the server has 10 websites and you don't provide the host header, it will just give you the default or the first website that it has. The user agent, it tells your browser software and version number. Telling the web server your browser software helps it to format the website properly for your browser if there's any compatibility issues. And also some elements of HTML, JavaScript, CSS are only available in certain browsers. Now the content length, when sending data to the web server, such as in a form, you're filling a form and you're sending that data, the content length tells the web server how much data to expect, so the web server can identify if it's missing any data or not. The accept encoding, it tells the server what types of compression methods the browser supports, so the data can be made smaller for transmitting over the internet, and this is for saving some bandwidth when sending requests. And lastly, the cookie header. The cookie data is sent to the server to help remember your information. Just think of it right now as authentication, and we'll get back to it later. When it comes to the server side, these are the common response headers. Set cookie, this is the information to store which gets sent back to the web server on each request. When you try to log into your account, you will receive a set cookie with a value, and then your browser will store it in the cookie jar, and on the next time your browser is trying to send a request, it will send it with the cookie flag. The cache control, for how long to store the content of the response in the browser's cache before it requests again. So this is to release some of the load on the server. Let's say I went to amazon.com to the default page, and there's another million users are trying to access that page. The server will cache that page and keep sending it to everyone without them accessing the server itself, so it frees some load. So the content type tells the client what type of data is being returned: HTML, CSS, JavaScript, images, etc. Using the content type header, the browser then knows how to process the data correctly. And lastly, the content encoding. This method is replied to the accept encoding header, and it tells it which method has been used to compress the data to make it smaller. So let's go to the question. What header tells the web server what browser is being used? That's the user agent. What header tells the browser what type of data is being returned? That's the content type, I think. And lastly, what header tells the web server which website is being requested? So this is the host header from the client side. And now let's move to the cookies. Let's view the site and let's start. You've probably heard of cookies before. They are just a small piece of data that's stored on your computer. It can be on the computer or your browser. Cookies are saved when you receive a set cookie header from the web server. Then every further request you make, you will send this cookie data back to the web server, and this will keep you authenticated on that server until the session ends or you log out again from the account. Because HTTP protocol is stateless, it doesn't keep track of your previous requests, meaning that even if you're logged in and you're trying to navigate to a different page, it might think that you did not complete the login process and kicks you out. So we need the cookie header to keep us authenticated on the website. Cookies can be used to remind the web server who you are, some personal settings for the website, or whether you've been to the website before. Let's take a look at an example. So here there's a client that's communicating with the server. This is the first request from the client, a normal GET request to the post cookies.thm, and now the server is responding with the 200 OK, meaning that it processed it well and it's telling me the data is an HTML. And then I sent a post request, as you can see here, and on the body of the request I sent my name, which is Adam, and this is probably to log into the website. And now the server is sending me a set cookie, a response with a set cookie that tells me that this is the cookie value. It can be something like that, or it can be just some gibberish words. The value usually is some unhuman, understandable text. So in this case it's name equal Adam, and now my browser will keep using this cookie whenever I'm trying to access that website for as long as the session is like cookie name equal Adam. And finally the web server now can recognize me and says welcome back Adam. And now the cookie can be used for many purposes, but are most commonly used to website authentication. The cookie value won't usually be a clear text string where you can see the password of the user, but a token, unique secret code that isn't easily humanly guessable. And now it's telling us how to view your cookie, and we can see the steps here. This is for Firefox. You go to more tools and then web developer tools, and let's view it in Chrome. More tools, developer tools, or you can just right click and inspect, and then you can go to the application and view your cookies there. So let's go to the questions. Which header is used to save cookies to your computer? That's the set cookie header. Finally, making a request. So this is the final task and it's a challenge. So let's access the site. This is an emulator for making demo HTTP requests. Using what you've learned from the previous task, can you use it to complete the below questions? So let's start with the questions. I will skip. Make a GET request to /room. So here we have a response and a request, and as you can see the method is GET and it's telling us to use /room. So we'll just add room here. As you can see it's changing here also. If I move this a little, we have the go, and now you can see the response 200 OK from the server. And here we have more headers, like the server header that tells us what's the server used, and this example is Nginx. So let's copy our flag. And now the second question, make a GET request to /blog. So let's change the room to blog, but we have an additional task, and using the gear icon, set the ID parameter to 1. Let's click on the gear icon. The ID is 1. Store that and proceed. Let's send it, and as you can see here we got our flag. And this one specifically on a normal request, how will you do that is by, since it's a GET request, so you need to add it on the header. So usually you'll do this question mark and you add your ID, but for now we have the gear icon to add stuff. And now let's change the method to delete, and the request is to /user/1. Let's delete the data that we had before. Proceed and go. As you can see here, the user got deleted. This is a bad security on the server side that anyone can delete, but this is just an example to show how the methods work. Make a bot request to /user/2 with the username parameter set to admin. So let's change it to bot, and the user is 2. So basically we're trying now to change the username of user2 to admin. Proceed and go. As you can see here, we've changed the username to admin, even though we did not know what's the username before that. And finally make a post request with the username thm and password let me in to /login. So let's change the path to login, the request type to a post, and here let's delete the previous username. Let's have our new username, which is thm. Store it with the password of let me in. Save that as well. Proceed and finally send the request. And with that we came to a conclusion with the first lab. I hope the lab was clear, and I will see you in the next one. Thank you.